Now see here, mean value or average value of the alternating current. Just we have done this equation, I is equal to I naught sin omega t, where I is instantaneous value of current and I naught is the peak value of current. And the graph of this with the time I and t is shown like this, that is the sine curve. But if you take from 0 to 1 time period here, that is in one cycle, average value of current is 0. But if you take for this positive half cycle or the negative half cycle, average value of current will not be 0. Since here the value of current is changing with the time, so we need to calculate average value of the current. So what is actually average value of current? How do we define this? For that, what we do here, first we take the alternating current, and in a circuit it is passed through the given time. Suppose first you are taking first half cycle. So take the AC, pass through the circuit for the time 0 to t by 2 and note down the value of the charge. Suppose let it be Q. Then what is the value of the steady current required to supply the same charge in the same time interval in the same circuit? So that steady value of current is known as average value or mean value of the AC here. So how do we calculate mean value of AC? So just see here, we know it I is equal to I naught sin omega t, that is instantaneous value of current, and similarly we know it E is equal to E naught sin omega t, that is instantaneous value of alternating EMF. So first thing is here, for the average value of this, we know it I is equal to here dq upon dt. I am taking this equation. Then we can write dq is equal to I dt, and then we can write dq is equal to I naught sin omega t dt. Now we have to calculate the charge supplied by this AC in the half time interval, first positive half cycle, that means. So we can integrate it, dq is equal to I naught sin omega t dt, that is 0 to t by 2. So we can integrate and calculate the total value of the charge supplied by the AC in time interval t by 2. So now we will be writing after integration here this part. This is here Q is equal to, we can write I naught is constant here, that is the peak value of current that can be taken out. Integration of sin omega t is here, that is minus cos omega t upon omega, that is 0 to t by 2. Now we can solve it, and just we will be getting here I naught upon omega, and here we can write minus cos 2 pi upon t into t by 2, that is the upper limit, minus lower limit plus, because minus minus will become plus here, that is cos 0. So this and this will get cancelled. So we will be getting I naught upon omega minus cos pi plus cos 0, and this is here cos pi, that is the minus 1. So it will be here I naught upon omega into 2, that is 2 I naught upon omega. So this is the charge supplied by AC in time interval t by 2. So suppose we can take here, if IAV or IM, any symbol we can write, with the value of is the value of a steady current, is the value of a steady current, then charge given by this current in the same time in the same circuit, that will be here Q is equal to I average into T upon 2. So this is the charge supplied by the steady current in the same time interval in the same circuit as is done by AC here. Now we can equate this and this equation. So we will be getting, when we equate these two, this and this, I average into T by 2 is equal to here twice of I naught upon omega. So this is the here now final equation here which we can solve it. So in this case we can write I average into T by 2 is equal to 2 I naught upon 2 pi here, that is into T. So this will get cancelled, and T will get cancelled. So, I average is equal to 2 I naught upon pi. So, this is the average value of AC in first positive half cycle. Similarly, we can get average value of his AC in negative half cycle, that will be coming here minus 2 I naught upon pi, and when we add these two values, so that means average value of AC over one cycle, that we will be getting 2 I naught upon pi minus 2 I naught upon pi, that will be equal to 0. So, this is the average value of AC in one cycle, that is coming equal to 0. It means if you connect a moving coil galvanometer with the AC source, it will be showing null deflection, because in one cycle the average current is 0. Similarly, we can calculate average value of EMF in the positive half cycle, that will be here, E average is equal to twice of E naught upon pi. Similarly, negative half cycle, that will be here minus 2 E naught upon pi, and over one cycle that will be equal to 0. So, in the same method we can devise a, we can define average value of EMF also.